I'm Anil Kumar sharing with you solution of a question from my subscriber Raymond. Now, thanks Raymond for posting excellent questions, and this probably is sixth or seventh which I'm doing for you. And keep posting. I like your questions. The question here is: P and Q are the feet of the perpendicular from A 0, 5 and B minus 6 0 to the line minus x plus 2y equals to 4. Find the vector equation of AP and BQ, the distance PQ, the position vector of the intersection of AQ with x-axis. Now, as I explained in one of my videos earlier, Raymond, I've changed your equation. Your equation was r dot, let me write down, r dot, so minus I plus 2j equals to 4, right? Now, some of my students do not really understand vectors. Therefore, I've changed this to a scalar form itself, but in a standard form, correct? However, you will understand the solution and you can modify the process as per your needs. So let's continue, okay? So both are same equations, okay? The first part is the vector equation of AP, right? So now, before getting into this, let me sketch the scenario and then we'll continue from there. So what we can do is we can sketch it here. Okay. So let's say x and y axis. So what we are given here is the equation of line minus x plus 2y equals to 4. So when you write minus x plus 2y equals to 4, we can find x and y intercepts. So x intercept is minus 4. So let's say this is minus 4. Let's keep it here. And the y-intercept will be 4 divided by 2, which is 2, right? So somewhere there. So join these two, we get a line. So I'll first sketch a line to be on the safe side and then form the point, right? So these are all very rough sketches. Okay, so let me just sketch a line here. Okay, so let this be the line which represents the equation, and this point for us now becomes 2. So we have minus 4 here and 2. Okay. P and Q are the feet of perpendicular from A, which is 0, 5. So let's say this point is A. 0, 5. Let's call this point A. When we say feet of perpendicular, that means we have to draw a perpendicular from here to the line, right? So if I drop this perpendicular, this point will become P for us, right? So this point is P for us, P. And B is minus 6, 0. So let's say B is somewhere here. Okay, let's take this as B, minus 6. And this point is B for us. Again, a perpendicular from here to the same line. Okay, same line. Okay. So we get a point Q on the line. Perfect. So that's our line. So this is the scenario. We need to find vector equation of AP and BQ. Vector equation of AP and BQ. Now, to my friends who do not understand vectors, I'll actually write down the scalar equation also. So just wait. Let me answer this question, which is vector equation of AP and BQ. Now, from this equation, we have a direction which is minus 1 and 2. So a perpendicular, these are perpendicular lines AP and BQ, both are parallel also. So their direction will be 2 minus, they will switch right. So the vector equation of AP, let me write down here, which is very simple, is point A, which is 0, 5. We take this as a position vector, 0, 5, right? Plus, let's say T, a parameter and the direction will be 2, 1, correct? Now if you do dot product of 2, 1 and minus 1, 2, you're going to get 0. That means these two are perpendicular, right? Orthogonal. So that serves the purpose. Similarly, for BQ, we could write the vector equation as the point B, which is minus 6, 0, plus some other parameter, let's say S. However, the direction is 2, 1, right? Okay, so we got the vector equation of this, and for my students who do not understand vectors, I will write the standard equation, correct? Now, the slope of this line is, if you reorganize, is half, correct? So this line could also be written as, let me change this line to 2y equals to x plus 4, which could be written as y equals to half x plus 2, right? 2 is a y-intercept, slope is half, you could see it right there. So the slope of this will be minus 2, right? Minus 2. And as some of you know, we can just flip this. These are also slopes of normal to the line. So what we can do is we can just flip this and write down the equation in standard form. So let me write down again the equation of AP. But this time I'm using a different strategy for my students who haven't learned this vector equation yet. So we could say this is 2x plus y equals to some k, right? Which is 2 in our case. 5 in our case, point A. And we know that the point A is 0, 5. So, if I substitute 0 here and 5 here, that means 0 plus 5 equals to k. Now I get my equation AP as 2x plus y equals to 5, right? I hope that's fine. Okay. Similarly, I can write down the equation BQ also, right? So BQ, since these two lines are parallel, so I don't have to bother about it, I can write 2x plus y equals to, let's say some other constant, let's say t. To find the value of t, we'll use point B, which is minus 6 and 0. So if I substitute 0 here and minus 6 there, I get 2 minus 6, which is 12, equals to t, and that is clearly minus 12. And that gives me BQ as, let me insert it here, 2x plus y equals to minus 12. Is it okay? So we get vector equations as these two equations, 1 and 2, and their counterparts, which if I bring 5 on this side will be called as scalar equation, right? Okay, so let's call them as 3, 4. But 1, 2, 3, 4 are actually the same equations. Vector equations, you could write many, but this is very specific, right? So that is how it is. So we got the equation part. Let's move on to the next page where I've copied the question, and we'll find the distance PQ. Okay, so let's move on. So what we did here was, is the same question here. P and Q are the feet of the perpendicular from A, 0, 5 and B, minus 6, 0 to the line minus 6 plus 2y equals to 4. Find the distance PQ. We already found the equations. So now what I will do here is that I'll write down both my equations, and the equations I'll write in scalar form, or the standard form, you can say, right? So AP equation, if I'm copying from there, it is 2x plus y minus 5 equals to 0. I brought it to the left side. And the other equation is BQ. BQ is again 2x plus y, and minus 12 becomes plus 12 when you bring on this side. So these are the two equations. Let me also sketch the diagram, and then, so I'll sketch a smaller diagram here. We might need a lot of calculations to be done. Okay. so let's sketch the diagram here. So diagram was something like this. We have a line oh, that's so close. Okay, where we found that the perpendicular from A, let me draw from here. This is A, and this is from B, right? So let's label it AB. This is -6, this is 5, okay. This is the point P, this is the point Q, origin O, right? So these are the values. This point is -4 and this point is 2 for us. So that is how we learned all this in our first part. Now we need to find distance PQ. As you can see, distance PQ is same as, let me write down here, is same as distance between parallel lines AP and BQ. Do you see that? So we don't even have to find the point of intersection and use distance formula. This is much shorter. So for some of you, you know this equation of line already given to us as -x plus 2y = 4. And use these lines to find P and Q, and then find distance PQ. But in this particular case, since we can find distance between parallel lines, we'll use the formula, right? Distance between parallel lines. So we say distance PQ is absolute value of, so if you write in standard form, the formula is C2 minus C1 over square root of A square plus B square, right? So that is the formula, right? So absolute value. Now in our case, what is C2 and what is C1? Well, whenever we do C2, C1, we have to make sure that AX, BY matches, right? Because A square plus B square, it matches here. So what we can do is we can do 12 minus -5. So we do 12 minus -5 divided by square root of A square means 2 square plus Y coefficient is 1, so 1 square. Do you get it? So we could write this as, and that's the absolute value, correct? So 12 plus 5 is 17, so we can write this as 17 over 4 plus 1, 5, square root 5. Do you get it? So PQ is 17 over square root 5. Some of you may like to rationalize this. Okay, you can do that also. So if you rationalize, you get 17 square root 5 over 5. That is perfect. So that becomes the distance PQ, which is same as the distance between these two parallel lines. So what we have used here is a strategy that distance between parallel lines is same as these 2 points. Perfect. Let's move on to part C. Well, those who find it difficult, they can actually find the point of intersections. We'll do for Q also. You can do the same thing for P. And then find the distance, okay? Part C is position vector of the intersection of AQ with x-axis. So that really means what we need to do is we have to connect them. Let me use another ink here, okay? So what we need to do is we need to connect AQ, and we are interested in finding that point. Do you understand? So it says position vector of the intersection of AQ, that means this vector, of AQ with the x-axis, that point we want, right? So that is what we will do. So basically now we will find the equation of line AQ and find intersection with PQ. So we need to find coordinates of point Q now. So that is very important. So let me take that in a fresh page. And so let's move on to part C of this question. The question is P and Q are the feet of the perpendicular from A 0, 5 and B -6, 0. to the line minus x plus 2y equals to 4, find the position vector of intersection of AQ with x-axis. So till now what we have done is really found all the equations. And now we'll use those equations to find the point of intersection, and then we'll know the solution, right? So let me re-sketch the diagram which we had. So we had to do it a couple of times. Let's say this is the diagram, okay. And let's drop the perpendiculars from A to this point. This is called P, and from here to here we'll call this as Q. Okay. A is at 5. This point is 2 for us. This is minus 4. This point is minus 6, and this is called B. Okay, this is called B. Okay, let's continue. Position vector of intersection of AQ. So we need to find equation AQ, and once we do that, we will know where it meets, correct? So that's the whole idea. Okay, we know it has to be between minus 4 and minus 6. That much we know for sure. So let's get back to our equations. We know equation of QP. First we have to find, so we know the equation of the line given to us. So let's say, okay, so we know equation of QP. QP is given to us as, let me write this as minus x plus 2y equals to 4, right? That is given to us. We know point B is B. So we also found the equation of BQ, right? Let's write BQ equation. I'll copy it from what we had developed in standard form, which was 2x plus y equals to 12 or minus 12. Let me check. It was minus 12. Okay. And we also know equation of AP. AP is 2x plus y equals to 5. 5 is the y-intercept, that gives you 5. Here's the page with you first. So we have copied these equations from here, right? So we have done this minus 12, and these two equations we have copied, and then we'll continue, right? Okay. So we have all the 3 lines and their equations. Now it's the elimination method or substitution method which helps. What we notice here is that both these are with 2x. So let me write QP as, let's multiply each by 2. So if I do that, we get minus 2x plus 4y equals to 8. Perfect. Now I want to find coordinates of point Q. So let's take the line BQ. So BQ is 2x plus y equals to minus 12. Now if I add these two, right? So I'm just doing addition here of both the lines. What do I get? They cancel off, and we get 5y equals to, adding means minus 4 here, or we get y equals to minus 4 over 5. Now, since y is minus 4 over 5, in this equation, I could also write x as equal to what, right? So let me write down from Q, let me write down, like taking x on this side, I can write x as equals to 2y minus 4. Is it okay? So what I did was, I reorganized. So now we know y is minus 4 over 5. And so what is x equals to? X is equals to 2 times y, right? Let me write 2 times y minus 4. And so x is equals to 2 times minus 4 over 5 minus 4. And that gives you 2 times minus 4 is minus 8. And 5 times 4 is minus 20. We have taken 5 as a common factor in the denominator. So that gives you minus 28 over 5, correct? So we get the point Q now. So for us, what is point Q? So point Q is basically the x value minus 28 over 5 and the y value minus 4 over 5. Is it okay? So that is Q. Correct. So we got the point Q now. We already know what A is. And we know what A is. A is 0, 5. Okay. So now we need to find equation of this line and its x-intercept. That is the answer. Perfect. So that is the answer. And how should we do it? Since it says vector equation, so let me go with the vector equation. So we are mixing and matching. So for my friends who are not doing vectors, you have 2 points. Find the equation of the line and then find its x-intercept, right? That's so simple. You know the y-intercept is 5, and that makes the things very simple. Y-intercept for AQ is 5. So now what we are trying to do here is find the equation of AQ. Knowing A, these are the points known to us, right? AQ. So I'll do the vector equation. Let's say R equals to A05 plus T times this minus this, right? So let me do 0 minus that. So it becomes 28 over 5, comma, 5 minus this. So 5 minus this will be 25 minus 4. So let me write 21 over 5. So should I write? So I'm doing a shortcut here. Okay. So basically I'm finding the 5 minus this. 5 times 5 is 25 minus 4 is 21. So this will be 21 over 5. How did I get it? Let me write down here direction. So the direction vector for AQ is going to be 0 minus 28 over 5, comma, 5 minus 4 over 5. Do you get it? 5 minus 4. So when I do that, minus becomes plus. 5 times 5 is 25. So it will be 29. That's good. 29 over 5, not 21, right? So 5 times 5 is 25. Minus becomes plus. So 29 over 5. Perfect. Okay. Now, this is the equation, vector equation of this line AQ. To find the x-intercept, we can quote the y value to be 0, right? So if I quote y to 0, what I get is 5 plus t times 29 over 5 equals to 0. So t will be equals to, taking 5 to this side, minus 5 times multiplying 5 over 29. Is it okay? So it is minus 25 over 29. So that is the value of t. So the x-intercept is what? So the x value of the intercept of our vector will be equals to 0 plus, that is 0 plus t times, t is minus 25 over 29 times 28 over 5. You get it, right? So that is what it is. So it is x-intercept is equal to, let's do this math. I know it gets multiplied, but we'll just do minus definitely. And we have 25 times 28 divided by 29. And then we'll divide by 5. So it gives us, in decimals, let's write down. So approximately, okay. So if you want to be exact, I'm sorry. So let's do it again. So it is 25 times 28 divided by 5, and then we divide this by 29, which is equals to minus 140 over 29. This is minus, that is why. And in decimals, it is, let's say 4.8. Is it okay? So minus 4.8. So it makes sense. It is between minus 4 and minus 6. So it's quite okay. So the position vector for this point, let's call this point as as t, for example. So the position vector for t will be equals to, so position vector you have to write in brackets. Do you see that? So minus 4.8 and the y value is 0. So that becomes the position vector of this. So that is the part C of this equation. So I hope the point is very clear. Those friends who want to write the equation of AQ in standard form, you know the 2 points, and then slope is y2 minus y1 divided by x2 minus x1, and so this divided by this is the slope. Once you know the slope, y-intercept is 5, and you get your equation, and from there you can find the x-intercept. So I hope that really helps both the parties. Feel free to make your suggestions. This was rather long. Anyway, I hope it helps. Thanks a lot again for sharing my videos, and if you like, that'll be great. Thank you, and all the best.